In this presentation, I will introduce the EURECOM 5G facility, which is a 5G platform that allows to run and trial vertical use case. The facility is composed by an outdoor deployment and indoor deployment. So in the top of this slide, you see the 5G facility in EURECOM premises in Sophia Antipolis in the southeast in France, where we have outdoor deployment to antenna and several indoor deployment using the concept of Cloud Run. So the facility allowed to run vertical services. Now the facility supports the ultra-reliable low latency service communication and massive machine type communication. For the second part, the facility allowed to deploy IoT using the standard NB-IoT, but also LTE-M. eMBB, which is enhanced mobile broadband, will be deployed in the near future, relying on millimeter waves. Note that the facility allowed to deploy a vertical service in form of microservices, which means that the facility is 100 compliant with cloud native support and deployment. The 5G connectivity in terms of radio is based on open air interface. So there are two expected deployments. So now the first one is already here, which is non-standalone deployment. A base station covering 4G is deployed on the band 38. And the second one for 5G, it's in the band N78. Both of them run in TDD mode. And the standalone is expected in before the end of 2021. Also, the facility includes a cluster of computing, which is a set of Dell server running Intel Gold and Silver microprocessor. Regarding the architecture of the facility, so we distinguish between three plans. So the first plan is the vertical user plan, where the trial is defined using a web portal. So this web portal allows to manage the trial and obtain the monitoring information on the trial. Its aim is to abstract as much as possible to the vertical the complexity of a 5G architecture and allow the trial owner to define the trial using an intuitive and user-friendly web graphical user interface. The second plan is the management and orchestration plan. So this plan is composed by a slice orchestrator. So this slice orchestrator receives from the web portal the definition of the trial. So this definition is a form of a network slice template. The slice orchestrator then parse this template and divide it into component because the trial will be run in form of a network slice. And as you may know, a network slice is composed by sub-slice running on different technological domain. So for the 5G facility of EURECOM, we have the RAN domain and the cloud edge domain, particularly the edge domain. So the RAN resources are described inside the NST, and this part corresponds to the RAN descriptor, and the part regarding the edge are defined inside the NST via the network service descriptor. So the orchestration plan also includes a RAN orchestrator that manage and enforce the slice at the RAN level, but also an NFVO that communicate with a virtual infrastructure manager in order to deploy the edge component. The NFVO also interact with the MEC platform, which is compliant with ETSI, which provide MEC services. The last component is the infrastructure plan, where we have the RAN component, as I mentioned before, relying on open air interface, the core network which is also relying on open air interface. The core network and part of the run are run as virtual instance. The facility support the Mac HC deployment, so it provides the Mac platform that allow to access to Mac services like RNES, traffic redirection, and so on, but also allow to run VNF and Mac application on top of the NFVI, which is the network function virtualization infrastructure. As I have mentioned before, the NFVI is supporting a cloud native deployment. So the Vim manager is in charge of deploying the services, which is described in the NSD on top of OpenShift or Kubernetes. So this slide shows the life cycle of a trial. So the web portal and the vertical are in charge of defining and preparing the trial. So the vertical will use the web portal to define a trial through a blueprint or use a pre-existing blueprint. It's defined the run resources which are allowed to user equipment and the application descriptor. So it includes information about the application service to be run at the edge by including a URL link of the images and other information on the resources needed by the different application. And the vertical select the KPI to measure in order to understand what is happening with during the trial. The second phase is the trial enforcement, which involve the web portal and the slice orchestrator. So the web portal will translate the trial descriptor according to what the vertical has entered through the graphical user interface into a network slice template, because as mentioned before, a trial is run on top of network slice, deploy the trial, and request monitoring from the slice orchestrator. The trial lifecycle management, which consists in receiving the KPI information, and also it's allow the vertical or the trial owner to update, for instance, the run or application resources. So 3 components are involved: the vertical, the web portal, and the slice orchestrator. And lastly, we have the trial deletion, which consists of deleting the network slice, stopping the KPI selection, and for instance, storing the trial the descriptor, which will be used later by the trial owner if he wants to deploy again the same trial. So for the KPI presentation, the web portal is showing the data coming from the trial and from the infrastructure in form of dashboard, so graphical user interface, or the trial owner can get directly the data in raw format. So the web portal architecture, so it's presented in this picture. According to 3GPP, the web portal and trial management could correspond to the CSMF entity, which is Consumer Service Management Function. So the web portal, as I mentioned, include the front end, which is graphical user interface, that allow to abstract the complexity of the definition of the trial. And then it includes different components that allow to enforce, manage, and monitor the trial. So the web portal is very important in our architecture because it's the interface with the vertical and should be as simple as possible in order to abstract the complexity of the architecture. Now, regarding the orchestration and management plan, as I have mentioned, EURECOM platform includes Slice Orchestrator, which is equivalent to 3GPP network slice management function. So it's manage the end-to-end slice. It uses a network slice template to deploy slice. So the network slice template is following the specification and recommendation from GSMA. It communicates with the run orchestrator and the NFView to deploy the sub-slices. So the run orchestrator and NFView could correspond to the network sub-slice management function. So the SO is implemented by EURECOM. It's a homemade implementation. Each provide a northbound API to manage the life cycle of a network slice. It's based on the 3GPP technical specification 28530. So it includes all the API provided, specified in this document to manage the life cycle of a network slice. In addition, the slice orchestrator provide a monitoring API in order to measure KPI, collect the KPI, and manage all the monitoring process, for instance, starting the monitoring process, stopping the monitoring process, and so on. Another important point which is done in regards of monitoring, the slice orchestrator aggregate monitoring per slice, because the sub-slice is running in a different technological domain which has different way to collect KPI. So these KPI are aggregated per slice and presented to the end user. The NFView, which corresponds to the network subslice instance management function as defined by 3GPP, it manages the life cycle of a subslice and manage monitoring to collect KPI. So the edge deployment is using an NSD, and all the application are based on application descriptor as specified by 8C. And as they have mentioned before, it supports a full cloud native microservice deployment. The run orchestrator, on the other hand, is managing the run subslices. It's enforce the run slice using the run descriptor obtained from the SO. The SO obtained this information through the NST. It manages the life cycle of the run subslice and trigger monitoring to collect run slice instance KPI. So for the NFView interaction with the Veeam, so the NFView is in charge of onboarding, offloading, instantiation, all the services included in the NST and the NSD. So as microservices in our case is deployed as an ABD. So the NFView communicate this information with the Veeam manager, which is following the container infrastructure manager, which is the recent specification of HC. And we have an image registry where the images are stored in order to be deployed on top of OpenShift or Kubernetes. It's important to note that also the NFView and the Veeam on top of OpenShift and Kubernetes has been developed from scratch by EURECOM, and it supports OpenShift deployment as well as Kubernetes deployment. So the Veeam, as I mentioned, support OpenShift and Kubernetes, and which means container deployment on bare metal directly. So we follow, if we refer to the HC definition, so it corresponds to the container infrastructure service management. So it provides lifecycle to onboard, offboard, instantiate, and manage in runtime the different container. It exposes API for lifecycle management, like status of ABD instance, containers, and also it's gather monitoring. It's deploy application in pods with multiple containers. One important point is the platform support the deployment of images of application in different format. So the Veeam, by parsing the update, finds the image where the application is stored, the virtual image of the container. It downloaded in the image registry and build it inside the cluster. And then it's pulled or pushed in the OpenShift local repository or the equivalent in Kubernetes. So we are accepting 4 ways to do it. So either the vertical provide a tar format using Podman or Docker Save, and provide an HTTP link where to download this image, or provide a Git repo where to build from a Docker file in order to push it to the OpenShift local repository. Public containers like Docker Hub or Red Hat Access, or an internal repo, which means that the images are present in a local repo and pre-downloaded. For the run orchestrator, we are using FlexRun controller, which is one of the tool present in Mosaic 5G. It's allow a run programmability of OpenAir interface. So it supports through its API enforcement of run slicing. It's allowed to create monitoring and collect data. So some data are based on FlexRun to be collected, but some are predicted and computed through different other KPI. It's important to note also that FlexRun is used to provide the radio network information service as provided by HC in order to present in real time and to be consumed by an application the channel quality indicator, RSRP, RSRQ per UE and per slice. So in the demo that you will see later, our objective is to deploy a microservice-based application for telemetry gathering and RNS display for flying drone. So the objective is to combine telemetry coming from drones with RNS coming from mech in order to track in real time the drone deployment and movement and its corresponding radio. So this is a northbound interface of the application. It shows on the premises of EURECOM a flying drone. So we obtain from the telemetry from the drone its position, its battery, and from mech RNS, we obtain the radio information. So as I said, it's combined telemetry information with radio information to understand the radio quality at the drone level. It's allowed to correlate with latency because we have script to compute latency and use the data to predict bad channel quality and assist for handover, in instance, to correspond to the usage of the application. This is in the context of the 5G drone project. So this is the component of the microservice for deploying this application. So the microservices is composed by GPS northbound, which display the position of drone in real time, in addition to the telemetry information, as well as the radio information. We have the GPS southbound that collect telemetry from the drones. And we have a database where information is stored, for instance, for further analysis. And the GPS northbound is also consuming from the mech edge platform through the MP1 interface, this RNS information. So as this is a microservices deployment, we need to configure a little bit these applications in order to create the services. So for the northbound, we have the database, which is Mongo database, where we need to provide the credential, address, IP port, IP address and port number, where to consume RNS information, and the port that are exposed by this northbound, which is port 80 toward the internet. The second microservices is GPS southbound, which also should know where is how to communicate with the MongoDB. The port which are exposed to outside, the port exposed to outside is UDP port toward the mobile network. It's allowed to collect the telemetry information from the drone and a DNS to be accessible from the drone. And this DNS allow to enforce the traffic redirection. And the MongoDB, so we can give information, we need information about the TCP port and to which network this port should be exposed. And since we are in microservices, remember, the database is exposing this TCP port inside the container network. You should note here that these three components, why we need this configuration, because this component will be deployed on demand through the NSD, which means that we don't know this IP address in advance and all this information. So therefore, this information will be passed to the Vim in order to create this microservice. So here an example of the application descriptor for the GPS southbound, which is exposing and gathering telemetry. So it's following, as I have mentioned, the MAC HC standard. And what is important from here is to see that the software image, it's available at the gate, and some other information like the minimum disk, the minimum RAM, and the number of CPU assigned to this GPS southbound microservice. And here you have the configuration that I have mentioned before. So we give all the information to configure the microservices, for instance, the credential to go to the Mongo, and for instance, the GPS, the port that are exposed. You remember we said that 5005 is a UDP port exposed to mobile network. And lastly, we need to indicate the domain name to be accessible from the drone, because remember, we need to enforce traffic redirection. Now it's time for the demo.